Hi, hello, welcome. Sarat Chandra Academy tarafuna NEET 2026 నిన్న అందరూ ఎగ్జామ్ రాసి ఉంటారు. మీకు రకరకాల ఫీడ్బ్యాక్స్ వచ్చి ఉంటాయి. మీరు కూడా ఏదో ఫీల్ అయి ఉంటారు ఫిజిక్స్ గురించి. బట్ నా ఒపీనియన్లో అయితే, నా పేరు SRR, ఇక్కడ సీనియర్ ఫిజిక్స్ ఫ్యాకల్టీ సరత్ చంద్ర అకాడమీలో. ఒకే ఒక మాటలో ఏం చెప్పాలంటే, ఫిజిక్స్ వెరీ సింపుల్ కాన్సెప్చువల్ గా ఇచ్చారు. ఏ ఒక్క బిట్ కూడా లెంగ్తీ ఆర్ టఫ్ క్యాలిక్యులేషన్స్ అట్లా బియాండ్ ద స్కోప్ వెళ్ళే ఛాన్స్ లేవు. అన్ని విత్ ఇన్ ద లిమిట్స్ ఇచ్చారు. ఇంకా చెప్పాలంటే, ఒక మంచి స్టూడెంట్ క్లాస్ నోట్స్ నుంచి మాక్సిమం బిట్స్ ని లిఫ్ట్ చేశారు. అంటే మీకు చాలా కాన్సెప్చువల్ గా కవర్ చేశారు. పేపర్ వీలైనంత సింపుల్ గా ఉంచడానికే ట్రై చేశారు. సో మనం సరత్ చంద్ర కాలేజీ తరఫున ఇప్పుడు మనం సొల్యూషన్స్ ఒకసారి ఎక్స్ప్లెయిన్ చేయడానికి ట్రై చేస్తున్నాం. వినండి, మీ డౌట్స్ ఏదైనా ఉంటే క్లారిటీ తెచ్చుకోండి. సో స్టార్ట్ చేద్దామండి ప్రోగ్రామ్. చూడండి, ఫస్ట్ మనకి సింపుల్ హార్మోనిక్ మోషన్ లో వేరియేషన్ ఆఫ్ కైనెటిక్ ఎనర్జీ విత్ టైం. ఇక్కడ మీరు చాలా సింపుల్ గా ఎలిమినేట్ కూడా చేసుకోవచ్చు. మనం కాన్సెప్ట్ స్టడీ చేస్తాం, బట్ హౌ టు ఎలిమినేట్ ఆప్షన్స్ కూడా ఒకటి చూసుకోవచ్చు మీరు. ఇక్కడ చూడండి, థర్డ్ ఆప్షన్ కైనెటిక్ ఎనర్జీ is given as a constant. In simple harmonic motion, potential energy, kinetic energy, both are varying continuously with position and time. So option 3 you can simply skip because it was given as a constant. And moreover, first option and second option also we can skip, because though the kinetic energy was a variable here, if you observe in the first and the second options, for half of the time the energy is on, means the graph is on positive side or higher side, but for the next half it was given on the lower side. Okay, so kinetic energy is a scalar and it won't change its sign during oscillations. So what we can easily put is this particular option. Why? Because with the time, in case of a simple harmonic pendulum, as we know, the kinetic energy of a simple harmonic oscillator follows this particular equation. Half m omega square a square cos square omega t. Here m, omega, a are constants. Those are not varying with the time. The one and only one variable is this cos square omega t. Because there is a square, this value is completely positive whether during time 0 to t by 2 or t by 2 to t. And we can simply eliminate these things, like in the first and second options, first half and the next half energies are in opposite order, opposite directions. And in the third it was given as a constant. Okay, so constant is not possible. This type of variation is also not possible. And you can simply see here the graph starts from a minimum in the sense Ke minimum. If you see a pendulum where it starts oscillation, it starts from the extreme. At extreme, velocity is 0. So kinetic energy is 0. So the graph starts from 0 and varies according to cos square omega t. So the correct option here is 4. I think మీ క్లారిటీ విత్ అనుకుంటున్నాను. ఇంకొకసారి చెప్తున్నాను. Half m omega square a square cos square omega t is the equation for kinetic energy, and the variable is here cos square omega t, and it is not possible to have any negative value or constant value. So the correct option is option 4. సరే, నెక్స్ట్ క్వశ్చన్ చూద్దాం. ఇది కరెంట్ హిస్టరీ నుంచి. మీకు ఇక్కడ there is a heater with 400 watt power and 220 volt rating voltage. And if the supply is 200, what will be the power consumed? It is straight from the book. It is a very simple idea involved here. Already we know the relation for power of a bulb or power of any device, P equal to V square by R, where P and V are the rated voltage and wattage. From that we can get resistance of the bulb using V square by P. And now, if the rated voltage is applied, the bulb can consume 400 watt. That means 400 joules per second. But instead of 220, what was given here? 200. So, prepare a new equation to find the power consumed. P dash equal to V dash square by R, where R is the resistance of the bulb and V dash is the new or the applied voltage. If the applied voltage is V dash and the resistance, since we are using the same bulb, the resistance is still V square by P. So finally, you can get a direct equation for this kind of problem. P dash equal to V dash by V whole square into P. That means applied voltage is what? 200. Rated voltage 220 whole square into old power. So you can do the calculation in very simple way. We can take the cancellation. This is 20 tens and this is 20 11s. If you got square, this is 100, this is 121. So after calculations, we can get, it is not possible to get 121, 200, 400, and with a simple calculation, we can get option 3 as the correct answer. So in one single word, if you want to memorize, this is the equation or the result. The power consumed when the applied voltage is other than rated voltage. V is the rated voltage, V dash is the applied voltage. Then the correct equation is P dash equal to V dash by V whole square into P. ఇది రెగ్యులర్ గా క్లాస్ లో టీచ్ చేసే ప్రాబ్లమే. సో చాలా సింపుల్ గా చేయొచ్చు. మీకు అర్థమైంది అనుకుంటున్నాను. నెక్స్ట్ సమ్ కి వెళ్దాం. ఓకే, నెక్స్ట్ మనం చూడండి. దిస్ ఈజ్ question number 3, it is from system of particles and rotational motion, and very simple concept. Even in kinematics, we know this type of equations in a very simple way. I think most of the students aware of this equation. S equal to U plus V by 2 into T. This is to find the displacement of a particle moving under uniform acceleration for time t. This we can convert into rotational motion also. U and V we can write as omega 1, omega 2, and time is t. Instead of linear displacement, we got angular displacement, and this angular displacement we can also write like, here N is the number of rotations, N1, N2 are the frequencies. In terms of omega, they are omega 1, omega 2. In terms of rotations per second, they are 2 pi N1 and 2 pi N2. If you take cancellation on both sides, you will get a very simple answer. N1, N2 are the initial RPS and final RPS. T is the time for the process. Then the number of rotations you can get by using a very simple value, N equal to N1 plus N2 by 2 into T. Just go and substitute. We need rotations per second, but here it is given in minutes. So divide with 60, divide with 60. In that way, 600 by 60, 10, 1200 by 60, 20. So just substitute. So 10 plus 20 by 2 into, what is the time? The time given is 10 seconds. So substitute that. Finally, we will get 10 plus 20 as 30, 35s are 150. So we have the answer 4. It is also a very standard model. Okay, in regular classes, generally we won't leave this problem at all. So equation calculation is also very simple. I hope you understand. We go for the next one. Okay, look here. This is also from oscillations, pendulum. The sum of kinetic energy and potential energy. That means the total energy of the simple harmonic particle is given as 0.02. And what they are asking? Speed of simple pendulum at the equilibrium position. Equilibrium is nothing but mean position, and at mean position the particle has maximum velocity. This already we know. So that's why the total energy of a simple harmonic oscillator we can write like half m omega square a square. In this, the maximum speed at the mean position is a omega. So simply we can convert this answer as half m into V max square. Don't worry, V max is nothing but velocity at the equilibrium position. So total energy equal to half m into V square. Substitute the values here. What is the total energy given to you? 0.02. Mass of the particle is given like 20 grams. Please convert into kgs. And the V max. So with a very simple calculation, we can do this. Here 2 ones, 2 tens. 0.02 we can also write like 2 into 10 power minus 2. Here also we have 10 power minus 2. So get cancelled. So V max here become root 2. Root 2 is 1.414. The correct option is option 4. So once again, go to the recap. Given the total energy, nothing but sum of P and Ke. This is the expression for total energy. In that, A omega we can replace with V max. So in one single line we can finish the problem. Total energy equal to half m into V maximum square. So substitute the values, and with a simple calculation, yes, we all know every day we are using root 2 as 1.414. So in a very simple manner you can get the answer. So next sum kelpodam. మనకి ప్రాబ్లం చాలా సింపుల్ కాన్సెప్ట్ నుంచి వచ్చింది. ఆల్రెడీ వి నో magnetic field strength at the center of a circular coil B equal to mu naught Ni by 2R. In this, every value was given except current. So you can finish it in a very simple way. I equal to 2R B by mu naught. Do the cancellations, then you will get radius as 5 into 10 power minus 2. B value, please convert this into pi into 10 power minus 3 for our convenience. And mu value was already given as 4 pi into 10 power minus 7. And n value, the number of turns, which is 100. You can even write like 10 power 2. Then everything got cancelled. The final thing is 5 by 2. 5 by 2 means 2.5. That means half of the answer we got. So we have two options with 2.5. That's why definitely we need to finish the second part also. That is magnetic moment. Magnetic moment of a circular coil of n turns is m equal to NIA. Already we know number of turns, and the current was calculated right now only 2.5. And the area, how we can get area of a circular coil? It is a very basic formula, pi r square. So please substitute all these things. And radius 5 centimeter. So finish the calculations so that you will get the correct answer. M equal to NiA. Finally, okay, after substitution, the nearly 1.96 like that vastundi. So approximate answer was given. And this problem is also from a very basic idea. Magnetic field at the center of a circular coil and magnetic moment of a current carrying coil. So ఇందులో కూడా పెద్ద ట్విస్ట్ అయితే ఏం లేదు, ఈజీగానే చేయొచ్చు. ఇట్ ఈస్ ఎ వెరీ బేసిక్ ఐడియా, మీరు అంతకన్నా ఎక్కువ థింక్ చేయాల్సిన పని లేదు. నెక్స్ట్ సమ్ వెళ్ళిపోదాం. Designed to withstand an absolute pressure of 100 atmosphere, how deep they can go or they can move it into the water surface. It's very simple idea. Here we have atmosphere, and now the submarine is submerged deep inside the water, and very simple, and the pressure at a point inside the liquid, whatever you call hydrostatic pressure or atmospheric pressure plus HDZ, where H is the depth of the liquid. If the liquid is water, it is very simple to finish the sum. Then HDZ equal to P minus P naught. Go to the calculations part. P minus P naught by dz. Here d is the density of the liquid. What liquid we have and what density was given? It is nearly 1000 kg per meter cube. Everything is given, and the pressure actually present is 100 atmosphere, and atmospheric pressure was already given. So totally 100 atmospheres minus 1 atmosphere by dz. So this is 99 atmosphere. As a reference, it was given 1 atmosphere is nearly 10 power 5. Density of water is 10 power 3, and G value is nearly taken as a 10. So finally, you will finish this answer in a rightful way as a 990 meter, which was given in option 2. So this is also a very regular and simple introduction part bit. So whenever you go to fluids, when they explain hydrostatic pressure, it is a very regular asking question. Even in the classrooms also, SARs will ask you what is the pressure inside the liquid. Even for board exams also, these models are there. So that's why it is not a panic one. In fluids, it is a very simple sum given. Pressure at a point inside a liquid is atmospheric pressure plus HDZ. So with simple calculation, we can finish. Everything was clean and right. Next sum will. Okay, next question kuchedam, 7th one. ఇది మీకు మోడర్న్ ఫిజిక్స్ లో ఎస్పెషల్లీ డ్యూయల్ నేచర్ నుంచి వచ్చిన మోడల్. ఆల్రెడీ ఈ మ్యాచింగ్ లో ఐ థింక్ ప్రతి ఒక్కరికి తెలిసింది ఈక్వల్ టు హెచ్ న్యూ. ద బెస్ట్ ఈక్వేషన్ ఇది మనం దేనికి రిలేట్ చేయొచ్చమ్మా? ఈక్వల్ హెచ్ న్యూ ఈజ్ ద ఎనర్జీ ఆఫ్ ఫోటాన్. I think all of you are very familiar with this. E equal to h nu, that equal to hc by lambda. So it is a very simply we can match a with 4 here, but with a4 a4 we have 3 options, but simply we can eliminate number 3. Next, diffraction and interference. Diffraction and interference. In what chapter you study all these things? In wave optics. In wave optics, whatever we deal is the wave nature of light only, wave nature of radiation only. So B goes to wave nature of light. That means B goes to option 3. So here given as option 1. So we can remove this also. Next, we need to decide from C. Okay, so very simple. Whatever that happened to the other options, leave it. So if you won't know, you are not a student of +2 also. Lambda equal to h by p is nothing but de Broglie wavelength. Whatever it is, physics or chemistry, all are familiar with this. I think this is the bit we can straightly put the option 2, because lambda equal to h by p related to wavelength. That is option C matches with Roman number 1, they'll list. So that is the only option present here. So it is also a very neat and clean bit. No need to worry about this. So next D1, Compton effect. Compton effect, maybe you may heard or not. Compton effect is the phenomena which explains how radiation behaves as a particle during scattering. That means when radiation interacts with material particles, how the wavelength changes. That change is called Compton shift. So Compton effect explains particle nature of radiation during scattering. So that scattering or whatever particle nature of light was already given. That's why here we are very clean in putting the options here, but okay, if you won't have time, you are in rush, you are in the last minute, you went to this question, it's very simple. The only one option with the C linked to 1 is option 2. In that way, మీరు accurate గా short time లో కూడా ఈ క్వశ్చన్ ఆన్సర్ చేయొచ్చు. నెక్స్ట్ బిట్ చూడండి, ఇది మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్ నుంచి. ఇందులో మీరు పెద్దగా చదవాల్సిన పని ఏం లేదు. ఈవెన్ ఫర్ ఐపీ ఆర్ బేసిక్స్ ఆల్సో మీకు ఇక్కడ ఉంటుంది. యంగ్స్ మాడ్యులస్. వెన్ ఇట్ కమ్స్ టు యంగ్స్ మాడ్యులస్, all of you know Young's modulus is nothing but ratio between longitudinal stress and longitudinal strain. For longitudinal strain, we will use delta L by L. Finally, this we can arrange as y equal to FL by A delta L. So Young's modulus linked to option 2 in list 2. And the compressibility. Compressibility is nothing but reciprocal of bulk modulus. That's why if you know bulk modulus, automatically you will come to know compressibility. That's why go to bulk modulus first. Bulk modulus equal to bulk stress by bulk strain. That's why bulk stress, it was given maybe like P, and bulk strain delta V by V. If you rearrange those things, that is minus PV by delta V. So bulk modulus we can link to option 4. And then compressibility. This is nothing but a reciprocal of this. Look into this. If you just reciprocate, this value you will get. And the last and final one, Poisson's ratio. Poisson's ratio, everyone know. It is the ratio between two strains, lateral contraction strain and longitudinal elongation strain. That's why this also we can easily identify as Poisson's ratio goes to first in the list 2. That's why see that the option where we have all these things in option 2. So it is right from textbook, no need to do any sum. It is from the introduction part. So in mechanical properties of solids, you go with the stress, strain, and then modulus of elasticity. At the last we got Poisson's ratio. Okay, here also no need to write anything on the paper to finish the problem. It is a very clear-cut problem. You can easily access to this. Next sum kelpoda. Right. The 9th one, here it is from electrostatics, whatever you call capacitors problem. So in this problem, C1, C2, C3, C4, everyone is given like 10 microfarad. That means these 4 capacitors are identical. And if you take these 4 capacitors as a series, since 4 identical capacitors were in parallel, in series, we can also get the effective capacitance of this particular row as 2.5 microfarad. Already C5 is also given as 2.5 microfarad. That means this problem you can reduce into 2 capacitors problem also, which were in parallel. As you know, in parallel, PD is same. Whatever the capacity, PD is the same for all in parallel. That means the 2 sections got 50 volts. And what they are asking here, the equivalent capacitance and the charges on each capacitor respectively. Look here, both have 50 volt, 50 volt. Okay, and the capacity of this portion is 2.5, this portion is 2.5. That's why by just using a simple equation Q equal to CV, we can finish this. 2.5 into 50. So finally it is 125 microcoulomb. So charge wise we got. Okay. In option 4 only there is 125 microcoulomb on all capacitors. That is the charge. Okay. Then what about the effective capacity? Very simple. Here finally the problem reduces into two capacitors. Each one is 2.5 and both are identical. When n identical capacitors were in parallel, we can use n into C. Here two capacitors, each 2.5. Finally this is 5. So don't get panic. Circuits with chala pedda samyam kaadu, chala simple. C1, C2, C3 are C3 and C4 are in series. Okay, so effective capacity 2.5 and the bottom one is also 2.5. Finally they were in parallel, so 2.5 plus 2.55. Whatever the way you follow, it is a very simple thing. So the correct option is fourth one. Next sum now. And the next student is gravitation nunchi. Gravitation lo chala important topic idi. Work done or changing potential energy when a body is taken to a height h from the surface. It is also a very simple idea. When you are initially on the surface of planet, the planet Earth, you have potential energy minus gmm by r, and finally when you reach a height h, your potential energy, because you are at a distance r plus h from the surface, r plus h from the center of the planet, you can go to this. And finally the work done in this problem is u final minus u initial. Final potential energy minus initial potential energy. And we can simply convert this into gmm by r into h by r plus h with a simple calculation subtraction. And here in this problem h is also given as r. That's why if you substitute, finally you will get gmm by 2r. But the answer was given in small m. With a simple calculation, the relation between small g and capital G, even for IP also, this is very important relation. From that, gm by r, you can replace with the zr. So gm by r, replace with the gr. So your answer is mgr by 2. It is also Pakka standard model. So you can even memorize the answer in terms of the procedure gmm by r into h by r plus h. Chala simple ga mere sum finish ayochu. Next sum kelpo. Okay, it is a very interesting sum and simple too. When a ruler, so one particular student is holding a ruler, that means simply in our language a scale. In that way 5 different persons, small g was given as 9.8, and when the scale is falling down, the 5 persons are reacting in different times. So reaction time means very simple, the time what you take to observe something and to react. So the reaction time given more means the body is allowed to fall for more time and your response is very slow. That's why here the person with the highest reaction time means person B. That means he allows that particular body to fall for more time. In that case, already we know for a freely falling body, the displacement or the height from which it falls become half zt square. So here HRS is directly proportional to t square. So what they are asking, the distance traveled, whether you take as S or H, no problem. S proportional to t square we need. And look at option 4. That means if you want to arrange this particular values in an order, just look into times. Whatever the orders given, here it is B greater than E greater than A greater than D greater than C means. Only thing is that options are given in the decreasing order of time or not, because in ascending order or in descending order, we just look into that. So here it starts with B. B means highest time. That means the body is allowed for more time. So B is the highest time and E is the least time. Remaining all arranged in this. So that's why by just using S proportional to T square, which is a famous equation for distance traveled by a freely falling body, you can finish the problem. I think indulo meer worry avadanaiki aithe em ledu. Next sum ki velipodam. Next చూడండి, ఇది పవర్ ఆఫ్ ఏ క్రేన్. ఓకే, ఇది మీరు చాలా సింపుల్ గా వన్ లైన్ లో ఫినిష్ చేసేసాం. ఇది చాలా స్టాండర్డ్ వన్. Power is nothing but rate of doing work. Here we are doing to just lift a body to a height h. That's why the energy spent here is mgh and the time is t. You just do the calculations part only. G value given as 9.8, height given as 20 and the time 10 seconds. We can finish in much simpler way and the final answer become 19,600 watt. Okay, if you want to convert into kilo, just divide with 1000 so that the answer will be 19.6 kilowatt. Once again I am telling, it is also from a very basic model. So rate of doing work or power to lift a body to a height h is P equal to mgh by T. Next 13th one చూడండి, ఇది కూడా చాలా స్టాండర్డ్ మోడల్. ఆల్రెడీ మీకు తెలిసింది, when a capacitor of capacitance C1 is connected to a capacitor of capacity C2, if their initial voltages are V1 and V2, you know the common voltage or the common potential in the problem after they were connected is C1 V1 plus C2 V2 by C1 plus C2. And also there is a very famous answer, half C1 C2 by C1 plus C2 into V1 minus V2 whole square. This is also expression for loss of energy. But here in this problem, one is charged to a voltage 100 and the another one is uncharged. Uncharged means just put the second voltage V2 as 0. If you substitute 0 there, you will get half C1 C2 by C1 plus C2 into V1 square. After putting all these values, you can simply get the answer, that is as per this option 3 you will get. So remember, it was also a straight question just to find the loss of energy when two capacitors were connected. One is charged, another is uncharged. Only simple formula, half C1 C2 by C1 plus C2 into V1 square, because the second one is uncharged. So that means this particular problem is also very convenient to solve, and final value half C1 C2 by C1 plus C2 into V1 square. The rest is calculation. We can get it is simple. And next sum kelpodam. 14th one చూడండి, AC circuit. In the AC circuit, there is a resistor of 1 kilo ohm, capacitor of 0.1 microfarad and inductance of 1 millihenry. Okay, this is the simplest bit in AC circuits. Everybody knows the resonant frequency formula. F equal to 1 by 2 pi root LC. This is the resonant frequency of LCR series circuit. So straight away you can finish the calculations. 2 pi into root L. Millihenry was given for L. So milli 10 power minus 3. And the capacitance was given as 0.1 microfarad. So micro means 10 power minus 6 This point 1 also, this point 1 we can also convert into 10 power minus 1. So finally you will get what out of the root. Inside the root we have minus 3, minus 1, minus 6. So totally minus 10 is there. If you move it to outside, it will become 10 power minus 5. That you can lift to the numerator. 10 power 5 by 2 pi. In the 10 power 5, you can convert into 100 into 10 power 3. Finally, there is 100 by 6.28. 10 cube you can write as a kilo. So 100 by 6.28. It is very close to 16. So the option 1 is given. So AC circuits లో ఇంతకన్నా సింపుల్ బిట్ ఉండదు అన్న లెవెల్లో ఇచ్చారు. కాబట్టి పేపర్ గురించి రకరకాల ఫీడ్బ్యాక్లు వస్తున్నాయి. సో మీరైతే డిసైడ్ చేసుకోండి. కాన్సెప్చువల్ గానే ఉంది, సింపుల్ మోడల్స్ ఉన్నాయి. సో ఇది ఏసీ సర్క్యూట్స్ లో ఇచ్చిన చాలా ఈజీ సమ్. నెక్స్ట్ సమ్కి వెళ్ళిపోదాం. ఓకే స్టూడెంట్స్, నెక్స్ట్ చూడండి 15th వన్. ఇది మూవింగ్ చార్జెస్ అండ్ మ్యాగ్నెటిజం నుంచి వచ్చింది. అండ్ మనకి ఇక్కడ ఇచ్చింది ఒక సర్క్యులర్ క్రాస్ సెక్షన్ ఉన్న వైర్. అండ్ మీకు ఇందులో ఇఫ్ యూ అబ్జర్వ్ ఇక్కడ మీకు ఫీల్డ్ స్ట్రెంగ్త్ ఎట్ ద సెంటర్ ఆఫ్ ద కండక్టర్ 0 అవుతుంది. అండ్ ఎట్ ఏ పాయింట్ బిట్వీన్ సెంటర్ అండ్ ద సర్ఫేస్ ఎట్ ఏ ఇన్సైడ్ పాయింట్ మీకు ఈ వాల్యూ mu naught I by 2 pi capital R square into small r అవుతుంది. అంటే there the field follows B proportional to small r. And very outside point, you know most of it. Outside point it is mu naught I by 2 pi r. That means on the axis the field is 0. Between the axis and surface the field increases linearly. At outside point the field is decreasing as B proportional to 1 by r. So that part of graph is rectangular hyperbola, and between center and surface there is a straight line. So there is only one graph with a straight line and rectangular hyperbola. So the correct answer is 3. Moving charges lo kuda idi chala simple bit. Next sum ki velipodam. చూడండి, ఇది కరెంట్ ఎలక్ట్రిసిటీలో పవర్ మోడల్. సారీ కరెంట్ ఎలక్ట్రిసిటీ పవర్ మోడలే, బట్ ఇట్ వాజ్ mixed with thermodynamics. So go to thermodynamics ideology also. So there is an electric heater supplies 100 watt energy. In that, work performed by the system is 75, and the rate at which internal energy, very simple idea, everyone knows, even for board exams also you deal with first law of thermodynamics. So du equal to dq minus dw. So the heat is 100 watt, means 100 joule per second, and the work performed out of that is 75 joule per second. So the remaining is 25 joule per second or 25 watt. So this is the internal energy increase per second, or the rate at which internal energy changes. So it is also straight from the basics. No need to worry whether it is from mixed concept or something else. So first law you are very familiar. You can finish in simple way. Next sum kelpodam. Next ఇక్కడ ఒక very simple cute problem ఉంది చూడండి. Alternating current. Peak value means the highest value. Frequency of the AC current is given, and what they are asking, time taken to reach from 0 to peak value. In AC circuits, mostly they give you a sinusoidal current equation. That means the equation which contains a linear sine function in the current, I equal to I naught sin omega t, etc. So this we can very simply finish. From 0 to highest value means from a phase 0 degree to 90 degree. Very simple. 0 to 90 degree means even in SHM also you will come to know this, or in wave motion also you will know this. Time taken to move from a 0 degree to 90 degree phase. 0 means if you put sign 0, the current becomes 0. If you put 90, the current becomes maximum. That means here they are asking what is the time taken by the current to change its phase from 0 to 90. That means for a 90 degree phase we need a time of capital T by 4, because capital T stands for 360 degrees, T by 2 stands for 180 degrees, then T by 4 stands for 90. Then you may ask, sir, where the time was given? Yes, time was not given, but frequency was given. And already we know frequency is nothing but reciprocal of time period. So n equal to 1 by t or t equal to 1 by n you can take, and then the required answer is actually t by 4, but we convert that into 1 by 4n, where n is given as 60, 64s are 240, so the valid answer is 2. So even in AC circuits also they are giving very basic level or preliminary idea sums. Don't get panic, ఇది చాలా simple question. Next, this is from wave optics. In wave optics, in YDSC, that means Young's double slit experiment, we have a very famous equation to find intensity at a point on the screen. I equal to I max cos square phi by 2, where I max is intensity at the central bright. If you go away from the central bright, gradually intensity decreases. At one moment you will get a dark fringe, and later on you will get bright. In this way, continuously if you wander on the screen, intensity changes. For that, this is the correct equation, and everyone should know this. And then here, intensity of light on the screen where the path difference is given. That means phase difference converted into path difference. This is a nice equation from progressive waves. We got the relation between phase difference and path difference as this. So from this you can prepare phi by 2. So this answer is very simple if you commit to this type of conversion. Just memorize this and convert into this. I equal to I max cos square pi by lambda into x. Okay, here the intensity of light at a point on the screen where the difference is lambda is k units. That means for us already one path difference and one intensity was given. Now they are asking intensity at other place where the path difference is lambda by 3. Simply we can do this as I2 by I1. I max is common, you can get cancelled, no problem. In the second case, that x is given as lambda by 3. In the first case, that x is given as lambda. So do cancellations, lambda get cancelled. So I2 by I1. Here you got cos 60 whole square. Cos 60 is 1 by 2, do the square, it is 1 by 4. And here it is cos pi, cos 180 minus 1, do the whole square, it is also 1. So finally, I2 by I1 equal to 1 by 4. I1 was already given as k, so your answer should be k by 4. So this is also straight from YDSC, it's a popular one. So path difference was given means x, phase difference given means phi. We can simply convert into these two, no problem. It is also a very simple model to solve. Next sum keldam. Yes, ఈ చాప్టర్ గెస్ట్ చేయండి. దిస్ ఈస్ ఫ్రమ్ న్యూక్లియై. స్టూడెంట్స్ నిన్న జరిగిన ఎగ్జామ్ లో టోటల్ మోడర్న్ ఫిజిక్స్ లో 8 క్వశ్చన్స్ ఉన్నాయి. సో డిఫరెంట్ టాపిక్స్ మీద. ఇది అలా మనకి న్యూక్లియస్ నుంచి వచ్చింది. చూడండి, ద వాల్యూమ్ ఆఫ్ ఎ న్యూక్లియస్ ఈస్ ప్రపోర్షనల్ టు ఏ క్యూబ్. ఇట్ ఈస్ ఏ బ్లండర్. వై? బికాస్ At the beginning or introduction part of the chapter, sir will say volume proportional to mass number. That was proposed by Rutherford. So that's why if V proportional to A is right, then V proportional to A power 1 by 3 is wrong. And moreover, a very simple definition was given. Mass defect, it is a familiar one. The mass defect is nothing but difference in mass of the nucleus and mass of its constituent. Constituent means the nucleus, whatever inside the nucleus, neutrons or protons, their mass is more than the mass of the nucleus. Once the nucleus forms, for its production or for its binding, it uses some of its mass, so mass decreases. So simply the mass defect is difference between mass of the nucleus and mass of the nucleons. So this is the correct way of expressing mass defect. So it is wrong. So finally, and our answer is B and D are correct, A and C are false. So no need to worry here, there is no calculation and hiccups also. It is also from a very simple idea, introduction part of the chapter only. Next question well. Next question number 20, interference and diffraction. Light energy is redistributed. Yes, this point we know it is a regular point. So interference and diffraction. Light energy is redistributed. Yes, correct. Producing a dark fringe increases in another region. Yes, this already we know. Okay. As there is no gain or no loss of energy, these phenomena are consistent with the principle of conservation of energy. Even for in board exam also there is a question like this for 4 marks. Explain the conservation of energy in interference and diffraction. So you must all know that statement A is true. And then about diffraction and interference. Diffraction and interference we know, but the thing is it was given like it is exhibited only by light waves. No, sound waves or whatever the waves we have, all the waves can perform diffraction and interference. That's why option B is clearly wrong, option A is right. So here also no need to use pen and paper. Right from your mind you can answer this. It is very simple, and even this is a heading of a 4 marks question in board exam also. Next question కి వెళ్ళిపోదాం. మళ్ళీ వచ్చిందమ్మా ఇది ఏం నొక్కాలి ఇదా సేవా పెన్నా ఓకే ఓకే Okay, student, next question. A resistor connected to a battery of 12 volt EMF and internal resistance 2 ohm. If the current in the circuit is 0.6, the terminal voltage, and all of you know this particular question, particularly in cells, when we have a cell with some internal resistance, the current in the circuit was also given, as the current leaves the particular cell is E, and inside of the cell there is an internal resistance. And this is connected to an external resistor. This picture already most of the people are able to memorize. In that, even the problem is not entered into the external resistance mode also. Very simple. It is a straight point. When the cell is discharging means when it is giving or deliver current to someone, the terminal PD is from the particular thing, V equal to E minus IR. That means out of E volts, the cell will lose IR volts because of internal resistance. That straight point was given as the question. So EMF is 12, the current is 0.6, and the internal resistance is 2. So this is 12 minus 1.2. Obviously the answer become 10.8. So in a very simple way you can finish this. This is from current density, and that simple equation V equal to E minus IR is enough to solve this problem. Okay, then this is whether it is from experiments or something. This is meter bridge in current density, and there is nothing to worry. Here the bridge was balanced or not, that was not at all mentioned, but very simple. Even in your lab also you will come to know. For example, this particular jockey is pressed at this first point A and then pressed at second point B, that means end of the wire. The deflections at A and B should be in opposite manner. At a particular place where we call as balancing point only, there is no deflection. So here in this problem, it was not mentioned clearly whether it is balanced or not, even though we can answer it. Between A to Z, if you put the pointer, the deflection if it is on the left, then between B to J, it should be on the right. That means somewhere it is left, somewhere it is right, but with one place, there is no deflection. That idea was expressed only in option 4. That means left side deflection, right side deflection, and no deflection are possible when you move the jockey from one end to other end of the wire. So here also there is no confusion, though no misclarity. So it is very simple. So that's why option 4 only you can go with. And look at this problem 23. There is a student who is measuring the simple pendulum's time period as 60 seconds for 30 oscillations. After giving all the data, what they are asking, length of the pendulum. Okay, it is a very familiar, all of you, it may be a favorite formula for all of you also. Then squaring on both sides, it is gt square by 4 pi square. G value given as 9.8. Time period we need to calculate, and pi square was also given as 9.8. Time period is nothing but time taken by total number of oscillations. So time taken is 60, oscillations 30. So the time period of this particular pendulum is 2 seconds, or nothing but seconds pendulum. So squaring on 4 get cancelled, and L equal to 1 meter. Actually, once if you know that clearly it is a seconds pendulum, there is no need to solve the problem at all, because for Z 9.8 means on earth, length of a seconds pendulum should be in and around 1 meter. So the only one correct option is this, and without knowing or unknowingly, you can finish the problem in a very simple way if you just know expression for time period. So this is also a very simple idea from oscillations. Next problem. Okay, it is also a question given as a statement type. Okay, so first we can also do the elimination also, or else if we know, we can go to the correct options to pick also. Number 1, inside the conductor, electrostatic field is 0. Every one of you definitely, you might know this, there is a good conductor. It never stores charge inside, and it never had a field at inside point. So the first statement is clearly correct. Second one, electric field at the surface. So this is wrong one, because the electric field strength on the surface of any charged conductor E equal to sigma by epsilon naught. That means definitely that is to depend on sigma. But here it is given does not depend. That's why It is the contradiction, so B is not correct. And option C, the interior of a charged conductor can have no excess charge in the static situation, right? Whatever the charge given to the conductor, that will move to the surface only because of the electrostatic repulsion. That's why they are saying there is no charge inside. That's why it is also right. And look at D. At the surface of a charged conductor, the electrostatic field must be normal to the surface. Yes, any electric field that starts from a conductor should start normally from the surface only. Otherwise, the charges on this particular body cannot be in static equilibrium. That's why it is also correct. And come to the final one, the electrostatic potential is zero everywhere inside a charged conductor. No, it is wrong. Inside of a conductor, which is a charged conductor, the potential inside is never equal to zero. Because field is zero, the potential becomes a constant. The particular constant value may be depend on size, shape, charge, etc. But clearly, any inside point of a conductor, it may not have electric field, but it should have potential. That potential is a constant, but what is given here? Zero. So it is also contradiction. So finally we got A, C, D. Where we have A, C, D only? In the option 1 only. So it is also the basic idea. If you just look as a formula, you cannot. If you understand the physics conceptually, it is very simple. Okay, 25th one student okkari. When the forward bias voltage across a PN junction diode increases above certain threshold voltage, the diode current increases. Yes, in forward bias of a diode, you have some VI graph if you have some slight memory. Up to a particular voltage, there may be no current because of the barrier. Later on, if you increase the voltage, the current increases. Yes, this is all correct regarding statement A. Then regarding statement B, this current is called reverse saturation current. This reverse saturation current term we can use in reverse bias only, not in forward bias. That's why clearly option B is wrong, option A is the correct. So where we have these things, answer option 3 only the correct answer pertaining to these statements. So it is also very simple. Up to now, whatever we discussed 25 questions, in that no one is a big calculation or out of the syllabus topic or whatever it is. So very simple, conceptual only. So if you go to the concepts, if you look into the notebook, you can find all these things. All the familiar models only are given for this particular 25 questions. Okay, next we will do in the next session. Okay, bye.
So, hello dear student. I'll continue with the remaining questions of physics, as first 25 questions was discussed by SRR sir. And remaining 20 questions I am going to discuss here. Okay, so let's start straightforward. So the 26th question: in a concave lens, a ray of light emanating from the object parallel to the principal axis of the lens after the refraction. So few options are given. So first, let's try to find out what they are talking about. They are talking about concave lens. When this is concave lens, which means it is a diverging one. So in the diverging one, you are having two situations. If this is my diverging lens, then there are two situations possible in which a ray becomes parallel after the refraction, or the parallel rays are coming and incident on the diverging lens. So suppose if rays becomes parallel after the refraction, that means the incident rays appears to converge at focus. Appears to converge at focus. Whereas if the rays are coming parallel, they becomes diverge, and they appears to diverge from the focus. So here they are playing with the basic definition of the focus, which will be given in NCERT. So if I read the question first, let me find out what is second and principal focus. What is the secondary focus and what is the principal focus? According to NCERT, the parallel rays are passing through the secondary focus, which is not the correct definition. The principal focus will be always, the first principal focus will be always on the side of the object, whereas the second will be always where the rays will be converging, the other side of the object. So if you see that in the first diagram, this is said to be your, because object will be on this side, so this is said to be your secondary focus, and here also this will be the primary focus, right? Because the object is on this side, right? So if I go through the options, passes through the secondary principal focus. So first you see that this particular situation is talking about which situation, the first one or second one? The first one or the second one? Since the rays are after the refraction becomes parallel, that means we are talking about this first situation. So the object, the incident rays are converging at the secondary focus. They appears at the secondary focus, while what is given here in the second option appears to diverge. So basically, according to the definition, it is wrong. But in NCERT, the same definition is given, so that's we are going with the option 2. Otherwise, this should be a bonus question. This should be a bonus question because none of the option will be true. Because the third option through 2F, definitely it is not correct. Emerges parallel to the principal axis is also not correct, right? Because parallel rays becomes not the parallel. Okay, after the refraction. So let's move to the second question. Okay, this is from the modern physics, basically nucleus. So they are talking about unknown nucleus has a nuclear density of 2.29. So density is given to you. Density is given to you and mass is also given to you. That means clearly with the help of mass and density we can find out the volume. And volume will be 4/3 into pi r cube. If we are treating the nucleus to be spherical, then its radius becomes r cube. So with the help of that, we can find out r of the nucleus. Now, since they are talking about unknown nucleus, so let us say its mass number will be a. That means this radius of the nucleus also we can write down in terms of the atomic mass, which is 4/3 into pi into r naught a to the power 1/3, which will be the relation of the hydrogen nucleus radius to the general radius of the nucleus of any atom to the power cube. So this way, this expression is turned out to be 4/3 pi into r naught cube into a, that will be equals to your V, right? Which is mass per unit density. That means what is A then? A will be 3m by 4 pi into density into r naught cube. Now, since all the values are given, we just substitute all the values, which is 3 into mass is given to you 19.926 into 10 to the power minus 27 divided by 4 into 3.14. Density becomes 2.29 into 10 to the power 17 into r naught is given to you 1.2 into 10 raised to the power minus 15 whole cube. So this way, after the calculation, when we calculate, we are getting the answer as 12. Right? So perfect answer will be there, which is 12. Okay, let's move to the next one now. Okay, now this is from current electricity, the conversion of a galvanometer into a meter of range 0 to 10. So as you can see that the maximum deflection current will be Ig. So what is the value of Ig? That is 1 milliampere. What is the range of the meter you want? That you want as 10 ampere. And you know that when we convert the galvanometer into a meter, we are connecting a very low resistance in parallel to the galvanometer, so that the maximum current will pass through the shunt. Okay, and this is Ig. So this will give you the voltmeter. For this, you can write down, you can equate the voltage across both the branches. One is through the shunt and one is through the galvanometer. Now here the shunt value will be Ig into G upon I minus Ig. Now what is Ig? Ig is 1 milliampere. G value will be 100 And I minus Ig, since the values are having lot of difference, like if you see I is 10 ampere, Ig is only 1 milliampere. So I is much greater than Ig. So for the approximation thing, I can only consider I, which will be my 10 ampere. So if you solve this, you can easily get it as 10 to the power minus 2, which is going to be 0.01 ohm. That is the option number 4. Alright. So again, a simple problem. Only till now, out of these 3 problems, the first problem was having little confusion. So that will be the bonus marks. And if we go according to the NCERT, which is actually wrong, we can go for second option. Okay. Move to the next one. Okay, now this belongs to 11th, rotational motion. We are talking about the moment of inertia. So moment of inertia of a ring. This is a ring which is made by a wire of length L. That means its circumference will be having the length L. So if I compare it with 2 pi r, we are getting the radius of this ring as L by 2 pi. And as you know that for the ring, this IC becomes the diameter, the axis which is passing through the center in this plane will be the diameter, which is mr square by 2. And this yy dash becomes the tangent. That's why by applying the parallel axis theorem, what we can get? We can get I into yy dash, that will be equals to IC plus MD square, which goes as mr square by 2 plus mr square, which is 3 by 2 mr square. Now, the point to be noted here, this m is not the mass, this is a linear mass density. So what is given here is the linear mass density, which is m. Don't confuse by the symbol. The symbol is though m, but it is what it is giving you, linear mass density. So to calculate the complete mass, I have to multiply small m into L, because L is the length of the wire, right? Because it is a linear mass density, which means it is the mass per unit length. Alright, so now substitute this value here, you are getting m into L, and this r value will be L by 2 pi whole square. Now after solving, your answer will be ml cube into 3 divided by 8 pi square. So 3 ml cube by 8 pi square is the option 3. Alright. So just this is a good question. You can say why, because they are playing with some of the terms like linear mass density and applying the parallel axis theorem. Okay. Let's move to the next question now. Okay. Now this question is the question from the simple question of a traveling wave, and they are talking about the 2 points which is separated by a distance 0.5. That means the path difference between the 2 points is given to you as 0.5 meter, which means we can find out the phase difference between them by simply k into delta x, or you can say this is simply 2 pi by lambda into delta x. Alright. Now to calculate this lambda thing, we can also see that where is lambda. So the term which is coming with x, that is 2 pi into 0.008. That will be the value of k. That means what is the value of 2 pi by k? That will be 1 upon 0.008, which is 1000 divided by 8 becomes 125. So directly you can get the value of 2 pi by k. Okay. Which is lambda. Right? So now this is 2 pi upon 125. X is given to you in centimeter, and this delta x is also we convert into centimeter, which is 50. So now this is 2, this is 5, this is 4 pi by 5. Now 4 pi by 5 is nothing but 0.8 pi, which belongs to option 3. Alright? Which belongs to, so pure definition, which very basic definition, by which in the wave and sound chapter we started with the very basic definition, like, so easy question. Okay, move to the next one now. Okay. So a box of mass 15 kg is kept on the floor of a stationary trolley. The coefficient of static friction between the box and the trolley is this. Keeping the box stationary straight over the pulley, over the trolley, what is the maximum acceleration of the trolley can have on the horizontal road? So suppose if this is a trolley and a box is kept over it. Obviously they are stationary. So here if you see this block is not connected to any of the string or somebody is holding it. Like it will be purely having the motion because of the friction. So either this question you can solve in the ground frame or you can solve in the frame of the trolley. So since the trolley is moving with some acceleration A, and if I want to use it, the frame of the trolley, that means I have to apply one pseudo force on it, which will be equals to ma, which is providing the tendency of this block to move backwards with respect to the trolley. That means the friction will be, tries to oppose it, so it will be in the forward direction. Now you see, more is the acceleration of the trolley, more is the tendency of sliding. That's why friction will be opposing it. So the friction can reach to the maximum limit, which is corresponding to the maximum acceleration of the trolley, which you can have without sliding. So if I equate these two forces, what I can say F max is equals to ma, means pseudo force, which is ma, and the maximum friction in this simple case, as you know that their normal will be mg, that means the maximum friction which you can have is mu n, which is mu mg, which is equals to ma, A max. So the value of A max will be mu g. Up here, we have to find out the maximum acceleration only. So I can write down the value of mu, which is 0.12, and g value is given as 10. So my maximum acceleration of the trolley can be 1.2 meter per second square. 1.2 meter per second square is the maximum acceleration which the trolley can have, so that the block will not slide over the surface of the trolley. All right. Okay, now let's move to the next one. Right. Now this is interesting one. This is interesting one. This is the diode, and we have to just judge what is the polarity, what is the reverse bias of, or what is the state of the diode. So as you can see, suppose they are talking about the sinusoidal graph. That means this is the positive half, this is the negative half. Suppose if I am taking the reference like this, positive and negative, then clearly you can say that in the first half of this AC source, this diode will be reverse biased. Whereas for the second half, when it is minus plus, this diode becomes in the forward biased. That means across the load, if the current is I, then I becomes 0, almost 0 in case of reverse bias, and I will be maximum, which is V by R in case of forward bias. So here we simply apply the KVL, and we will say that the voltage across the across the diode plus the voltage across the load, that will be the voltage across the AC source. Up here, if they are asking the voltage across the load, then the student might have confused that says the current is 0, so there will be no voltage across the load. But here they are playing with the language of the question, which says across the diode. That means though the voltage across the load is 0 in reverse bias, but across the diode it has to be same as the voltage which is across the AC source. All right. That's why if this is having positive half, that means same is the voltage across the diode, and for the reverse bias, since the entire load will be across the load, that means through the diode it becomes 0. All right. So it is in the first half, if it is same as the voltage across the AC source, but for the second half it becomes 0, because we are not looking for across the load, we are looking for voltage across the diode. All right. If it is the same graph between the load, then for the load you can say, sir, it is 0, and for the second half it will be like positive. But since it is across the diode, that's why your correct answer goes with fourth option. All right. Okay, let's move to the next one now. Fine. Again, another simple question. They are trying to confuse you in this question from heat and thermodynamics. They are trying to confuse you by giving the masses. So if you are looking for the masses are in the ratio of 2:1. Masses are in the ratio of 2:1. Masses are in the ratio of 2:1. So mass of argon upon mass of chlorine, that is given in the ratio of 2:1, right? And talking about VRMS, if I am talking about VRMS, then it goes as gamma T by M. No. Gamma T by M is what? That is the velocity of sound. We are talking about RMS, which means it goes as VRMS is what? It is simply 3 RT by M. Alright, so 3 RT by M. So clearly you can see that here is not the role of masses, here is the role of molar mass. That means to find out this ratio, that it is the velocity across RMS velocity across argon to the RMS velocity across Cl, it will be simply the molar mass of the argon to the molar mass of the chlorine, which is given directly as 70 AMU divided by 40. Okay, so root 7 by 4 becomes root 7 by 2. Third option. Okay, so let's move to the next question now. Okay, so match of the following. Oh, direct theory question. Microwaves. Out of these 4 options is Kriston values. Okay, because basically Kriston values is used to produce the microwaves by velocity modulation in the electron beam. Okay, so direct theory question, that this will be option 1. Visible light, you very well know, Balmer series when it will be generated, when the atom will be excited to the higher energy state, and while coming back it will be emitted the radiation which belongs to visible range. Okay, so it goes to B goes to option 1. If first goes to option 4. Gamma rays, radioactive decay, and infrared rays, vibration of the molecules and the atoms. So if you see the option, first one is 4. So these 2 are vanishes out. B will be first one. Only option will be, so 4th and 1st. Just by checking the 2 options only, you can conclude to the final answer, which will be option 4. Okay. Move to the next. Okay, next question is question number 35. The magnitude and direction of the acceleration. Okay, so simple question of laws of motion, right? A body of mass 5 kg with the 2 mutually perpendicular forces. So if the 2 forces are acting on this body, so let's draw a body on which there are 2 forces acting, F1 as 8 Newton and F2 as 6 Newton. Then to get the resultant, we can directly say F is equals to under root of F1 square plus F2 square. Alright. Find out its acceleration. One point to be noted, they are saying 2 mutually perpendicular, they are not talking about any other force. So basically this diagram is also not the perfect diagram, because we are talking about the forces in the perpendicular direction. So you might have think that it will be balanced by mg, but it is not. So you have to consider in this way, that let us say this is some plane in which the body will be there and 2 forces are there, which is of 8 Newton and 6 Newton. So it will give you the net force, and that net force will be clearly under root of 6 square plus 8 square becomes 10 Newton. That 10 Newton force, so basic knowledge of vector is telling you this theta, that this theta should be equals to in the direction of tan inverse of 6 by 8, means the total overall force will be 10 Newton, which is in the direction of tan inverse of 6 by 8, means tan inverse of 3 by 4 with 8 Newton force. Therefore, if I am interested in the acceleration part, then pure definition of the Newton's law says that A equals to F by M. A is equals to F by M, that means it is 10 divided by 5. A equals to 2 meter per second square in the direction tan inverse of 3 by 4, and this direction is with what? This direction is with the force of 8 Newton. Is your right answer. So what is the answer out of these given options? It is 2 meter per second square, tan inverse of 3 by 4 with 8 Newton force, option 1. Okay, move to the next question quickly. 36, again a diode one. So with this polarity, these all are positive terminals. These all are negative terminals. So which of the diode will be reverse biased? This diode will be reverse biased. This diode will be reverse biased. Right? That means these branches will be treated as open branches. Why? Because there will be no current in this. So your simplified circuit will be this. Now you have only the top one and you have the middle one. Because these two are only in the forward bias and this is 10. So now you can quickly find out the R equivalent. So R equivalent for this is R1, R2 because both are parallel, that is 4 by 3. And then you can find out the current which is E by R equivalent, that is 10 divided by 4 by 3. 10 divided by 4 by 3 becomes 15 by 2 ampere is the answer. So 15 by 2 ampere is the answer for this question. Alright, simple one. Till now overall questions are going simple only, okay? But some disputed question definitely there for which you are getting bonus. Okay, move to the next one. For a metal of work function 6.6, which of the following wavelength is incident radiation does not rise to a photoelectric effect? So you know that there is a work function which will be the minimum energy of the photons which you needed for ejection of the photoelectrons. That means you can calculate this lambda, which will be SC by 5 work function. Alright, this value will be 12375 divided by 6.6. Alright, this way you can clearly see that this value will be less than 200 nm. Any value will be less than 200 nm, right? If lambda will be less than this lambda naught, then energy will be, then lambda will be less, energy will be more. Okay, if lambda will be more than lambda naught, that energy will be less than the work function. So for all these conditions, what will happen? If lambda is greater than lambda naught, the photoelectron emission will not take place. But for this, it will be takes place because this can be the maximum lambda, threshold lambda, right? So now value which is below 200, at all those values, the photoelectron emission will take place. But at 200, it will not take place, right? So that means which is the incident radiation does not rise to the photoelectric effect. Answer is 200 nm. Okay, move to the next one. The speed of light in vacuum is taken to be unity. Fine. It takes 6 minutes 40 seconds to reach to the earth. Find out the distance. So speed and time is given to you. You have to find out distance. Distance is equals to speed into time. Only thing, they are using different units. So which unit they are using? They are using some other system of unit in which the speed is 1 unity. That means this will be one of the new unit. This velocity will be one of the new unit and time will be 6 minutes 40 seconds. So convert 6 minutes into 40 seconds into seconds, which is 6 into 60, 360 plus 40. So it comes out as 360 plus 40 is 400 seconds. Now when we multiply 400, what we are getting? We are getting the distance as 400 in a new unit. So correct answer is 400. So I think simplest question, huh? Distance is equals to velocity into time. Okay. Move to the next one. Move to the next one. 39. A rectangular wire of the loop of side 8 cm and 3 cm is having the small cut, is moving out in the region of the magnetic field with the magnitude 0.3 Tesla. The EMF developed across the cut is if the velocity is. So we have to find out the EMF. And the direction is normal to the direction of velocity is normal to the shortest side. Okay. So suppose if this is the loop, and they are saying the direction of velocity will be towards the shorter side. So I'm assuming this side to be 3 centimeters, this side to be 8 centimeters. So the direction will be perpendicular to the shorter side. Shorter side is 3, it is perpendicular to it. So now if it is cut, so you can see this in a reverse way. Reverse way in the sense, if it is in a magnetic field and let us say this loop is complete, then there will be no change in flux. So if there is no change in flux for the complete loop, then EMF will be 0. But it is not 0 because of this portion will be not encountered by this portion, correct? That means for the complete EMF, we can only consider this much of amount of the length, which will be the length of the cut part. And how much length will be there with a small part? 3 centimeter of it. The reason E induced is equals to BVL. So what is B? B is 0.3 Tesla. What is V? V will be given to you 2 centimeter. 2 centimeter means 2 into 10 to the power minus 2 into. Now since they are saying this, there will be, I think there will be a mistake, because they should give the length of this cut. Length of this cut. Anyways, it's calculated by 3. So suppose if I'm taking 3 centimeter, by assuming that entire side will not be there, entire short side will not be there, or maybe it will be out of the magnetic field. So only the EMF will be generated through this side. Okay? Okay, let me explain again what they are saying. It is coming out from the magnetic field. So suppose if this portion will be coming out, then for the entire loop, the EMF will be only generated to the shorter side. That's why, what is the length you are taking? You are taking this length as 3 centimeter, which is in SI unit is 3 into 10 to the power minus 2 meters. When I calculate this thing, it is 3 into 3, 9 into 2, that is 1.8 into 10 to the power minus 4. Okay, so it is matches with your answer, right? That means in this question, if they are talking about that complete loop will be inside, then they should give the length of this part which is being cut off. Or otherwise, you have to read it in this way, that it is coming out from the loop means there will be no magnetic field outside. That means whatever EMF is generated, it is only generated because of the length, the shorter length which will be inside. And then only your answer can match with 1.8 into 10 to the power minus 4, right? Okay, move to the next one now. Oh, this is a very common question. Almost in many tests, and many times we did this type of question, that when a ball is thrown up, under gravity, then first its velocity will be decreases to 0, and then it is increases again in the downward direction. So if you take the sign convention as positive upside and negative on the downside, then that means your initial velocity will be positive u, which will be decreases to 0, and finally it is now increases in the negative direction and it becomes minus u. That means you have to continue this graph in a straight line. That's why correct option will be C. So very general question. Many times it was discussed in the class also. Let's move to the next one. Question number 41. In a Vernier calipers, 20 VSD coincide with the 16 MSD. Each one of the division is of length 1 mm. Least count. So first, how many divisions are there? 20 Vernier scale divisions are equivalent to 16 divisions of MSD, whose value will be 16 into 1 mm, because one division is equivalent to 1 mm. That means one Vernier scale division is equivalent to 16 by 20 mm, which will be 0.8 mm. Alright, now since we have to find out the least count, and least count is nothing but the difference of one main scale division to the one Vernier scale division, that will be 1 minus 0.8. This answer will be 0.2 in mm. So convert into centimeter, that will be 0.02 in centimeter. It goes with the option 3. Alright, straightforward question. Okay, question number 42. Each side of a metallic cube is 5.580 kg, is measured to be 9 centimeter. Keeping the significant figure in view, the density of the material can be expressed as x into 10 to the power 3. Find out the value of x. Okay, so when we are talking about the density, it is simply, the density will be simply equals to mass upon volume. All right, mass is given to you 5.580, and since it is a cube, so the cube will be having the volume a cube, the side cube, that means 5.580 kg divided by 9 centimeter, which is 9 into 10 to the power minus 2 whole cube. So when you solve this, this will be coming 7.654 into 10 raised to the power 3 kg per meter cube. Now here, this calculation is fine, but what they are talking about? They are talking about significant figure. So what is the rule of significant figure in multiplication and division? We have to keep it in the least significant figures which is used. So if you check in the first term of the mass, how many significant figures are there? 4. But in this side term, we have the only 2 significant figures. That means my answer should be converted into 2 significant figures. That means we have to round it this off to 1 decimal place. There will be some confusion that when we are talking about on the meter scale, generally the convention which I follow, that on the meter scale, if suppose this thing is 1, this is 2, and this is 0.5 in between, 1.5. If you are on this side, then you better to take the value after rounding off as 2. If your value will be after rounding of terms will be less than 0.5, then you can take the value which is the lesser one. So here if you see 5.4 means it is more than 0.5, so this should be converted into 7.7 into 10 to the power 3. That means the correct answer goes with 7.7. But there can be discrepancy also. We can also do this like 7.654. 4 is an even number. So 4 is an even number. So when you round it off, there will be no change in the current figure, which will be 5 only. And for 5, there will be no change in 6 also. Right? So answer could be 7.6. But most appropriate will be 7.7 only. Though some of them can claim it will be 7.6. But the right answer for which you should go for is 7.7 only. Let's move to the next one. Some 2-3 questions left only. Again, for this is prism, and in prism this is again the most common question which will be done in the class many times. When this base and when this ray is parallel, what does it mean? It means both the angles are symmetric. R1 and R2 are symmetric. So if R1 is equals to R2 is A by 2, which is 30 degree each, then how to get this deviation? You can get this deviation as I plus E minus R1 plus R2, which is A. Alright, now I is already given to you 50 and we have to find out the deviation. So I is given to you 50, what about E? Since R1 is equals to R2, that means I is also equals to E. That means your E will be also 50 minus R1 plus R2, that is 60. So directly you are getting the answer as 100 minus 60, which is 40. So 40 degree will be your answer, which goes with the option D. Goes with the option 4. All right. Okay. Now 2 more questions. Question number 44. In the first exciting state of the hydrogen atom, the energy of the electron is 3.4 eV. The radial distance of the electron to the hydrogen nucleus will be. So in the Bohr's model, you very well know hydrogen-like atom means there is a nucleus and there will be one electron which is revolving. And in the hydrogen atom first exciting state, so you can say positive charge is also E, negative charge is also E. And the total energy in the orbit, you write down this as K Q1 Q2 by 2R. So it is K Q1 Q2 by 2R, because kinetic energy and potential energy sum will be minus of that, right? Here this value will be minus 3.4 eV as given. This K will be 9 into 10 to the power 9. E will be plus E minus E will be 1.6 into 10 to the power minus 19 whole square, and R. So R will be R we have to find out. So it is by 2R. Also take care of this thing. This is EV. So first convert it into joules, which will be by multiplying 1.6 into 10 to the power minus 90. That means 1 will be cancelled. And directly you can get your R value as 9 into 1.6 divided by 3.4 into what is left, 10 to the power minus 10 meters. All right, this is approximately 2 point something, this is approximately 2.1. So 2.1 into 10 to the power minus 10. So even the calculation is also very simple. Directly you can give the answer as 2.1 into 10 to the power minus 10 meter, okay, or 2.1 angstrom. Then the last question of the paper is a uniform metallic wire having the resistance 4 ohm is bent in the form of the square loop ABCD. So this is ABCD, this wire ABCD, the total resistance of this is 4 ohm. That means each side is identical. That means each side will be 1 ohm, 1 ohm, 1 ohm, 1 ohm. Now I think after this, it will be very easy to identify that this circuit is nothing but this circuit is a Wheatstone bridge with R1 by R2 is equals to R3 by R4. That means this 2 ohm will be cancelled out. Okay, it's a balanced Wheatstone bridge. So what is its R equivalent, bacho? Its R equivalent will be this 1 plus 1 becomes 2, this 1 plus 1 becomes 2, and this 2 and 2 in parallel will give you 2 by 2. So overall resistance will be 1 ohm. If overall resistance will be 1 ohm, what will be the current in the entire circuit? The main current which is drawn from the battery is E by R equivalent. E will be 2 volt, R equivalent is 1, that means your answer will be 2 ampere, which is option 4. Okay, so this is it about the question. Overall, the question difficulty level is easy. Some of the questions are moderate. Calculation wise, they are super easy. There will be no big calculations. Yes, 1 or 2 questions are having some ambiguity in the language, or you can say there will be, they say, one question of optics, one question of this, and some of the questions will be very interesting also, like you have to very keenly observe the language of the question, so that, because the question like diode, in which they are asking the voltage across the diode, though we are habitual to calculate the voltage across the load. Okay, so this type of question will make this paper slightly good also, so that you have to think, you have to use your presence of mind while reading the question. Otherwise, the overall question paper will be easy only. Okay, all the very best.